Assalamualaikum. My name is MAT183 and my student number is 20258914552. And today I will discuss question number 1. Explain the meaning of differentiation. Differentiation is a process of finding a variable which is that x with respect to x is the function of f on x. What are the techniques of differentiation? We have the first one is power rule. It is to differentiate power of x. The second one, constant rule. It is the derivative of a constant is 0. The third one, floating rule. It is used when a function is divided by another. The fourth one, chain rule. It is when a function is inside another function. The next one is product rule. It is when two functions are multiplied. The next one, trigonometric rule. It is to differentiate sine, cosine, tangent, and another trigonometric function. After that, we have exponential rule. It is differentiating exponential functions. Another one, logarithmic rule. It is to differentiating logarithmic function. And the last one, generalized power rule. It is an expression of the power rule in the base is the function.
Assalamualaikum. My name is Alia Amani binti Muhammad Tulha. So for question 2, we will find dy over dx for the following function. So for question A, y equal to ln 2 plus x power of 3 sec 2 minus x. So we will get u and v here. So for u is equal ln 2 plus x power of 3 and v is equal to sec 2 minus x. So for u prime, which is 3 x power of 2 over 2 plus x power of 3. And for v prime, negative sec 2 minus x, then 2 minus x. So for this question, we will use product rules, which is dy over dx equal to vu prime plus uv prime. So we just conclude it here, which is dy over dx equal to sec 2 minus x multiply 3x power of 2 over 2 plus x power of 3 plus ln 2x plus x power of 3 multiple negative sec 2 minus x then 2 minus x. And the answer for this question is dy over dx 3x power of 2 sec 2 minus x over 2 plus x power of 3 minus ln 2 plus x power of 3 sec 2 minus x and then 2 minus x.
Hi, my name is Alia Fakihah binti Azami Pariza. Today I will explain about question 2b. Okay, 2b is y equal to exponent power of 3x squared divided by 10x. Numerator is exponential function and denominator is trigonometric function. Since one function is divided by another function, we can use quotient rule formula, which is dy over dx equal to vu prime minus uv prime over v squared. So here, we let u as e power of 3x squared and v we let as denominator, which is 10x. After that, we need to find u prime and v prime, which is u prime is differentiation of u and v prime is differentiation of v. So let differentiate u first. Since there are two type of function in one function, first we need to differentiate the main function. Second, we need to differentiate the inner function. Then we differentiate this, we got the same, and we differentiate the inner function, we got 6x. Then the final is 6x exponent power of 3x squared. Then we differentiate v to find v prime. We got secant square x. We need to substitute u, v, u prime, and v prime into the quotient rule formula. Then we got dy over dx equal to 10x multiply 6x exponent power of 3x square minus exponent power of 3x square multiply secant square x over 10x power of 2. Since from the left and from the right we have the same function, which is exponent power of 3x squared, we can factor out and we substitute the excess function in the bracket. We got exponent power of 3x squared bracket 6x 10x minus secant square x over 10x power of 2, we got 10 square x, and that's the final answer. Thank you.
Assalamualaikum everyone, my name is Nur Fatihah Kasim binti Zaim, and today I would like to present the solution for question 3 using implicit differentiation. So, the given equation is cos power of 4 exponent 2y minus x power of 3 minus ln y power of 2 equal to 4xy. First, I label each term. cos power of 4 exponent to y minus x power of 3 as term A, and ln y power of 2 as term B, and last 4xy as term C. For term A, we need to put the power of 4 outside the bracket. So, for A equal to cos exponent to y minus x power of 3 close bracket power of 4. Now, we need to differentiate term A. The first one we need to differentiate term A is power of 4. The second one is cos, and last but not least, exponent to y minus x power of 3. Then, for A prime, I will differentiate by using the chain rule, which is the first step for cos power of 3 exponent to y minus x power of 3. Next, differentiate second step for cos, which is we need to multiply with negative sign exponent to y minus x power of 3. Plus, for exponent to y minus x power of 3, which is we need to multiply with exponent to y multiply with 2 dy over dx, and then minus 3x power of 2. And then we can simplify the equation again. So the final equation for A prime is negative 4 cos power of 3 exponent to y minus x power of 3, and multiply with sine exponent to y minus x power of 3, and then multiply again with 2 exponent power of 2y dy over dx minus 3x power of 2. So next we go to the next step, which is term B. B equal to ln y power of 2. So B prime equal to 1 over y power of 2 multiply with 2y dy over dx, and then we can cancel out 2y over y power of 2 dy over dx. So the final equation for B prime 2 over y dy over dx. Next, for term C is for xy. So we use the product rule, and then the formula for product rule is uv prime plus vu prime. Okay. So u is 4x, and then u prime is 4. V is y, and then v prime is 1 multiply with dy over dx. So the answer is dy over dx. And then how do we get the C prime is 4x multiply with dy over dx plus y multiply with 4. So the final equation for C prime is 4x dy over dx plus 4y. Okay. And then we need to substitute the equation in the first equation, this. Then it becomes like this, negative 4 cos power of 3 exponent to y minus x power of 3 multiply with sine exponent to y minus x power of 3, and then multiply again to exponent power of 2y dy over dx minus 3x power of 2, and then minus 2 over y multiply with dy over dx equal to 4x dy over dx plus 4y. So this is term A, and then this is term B, and the last one is term C. So the first step we need to solve it is we need to multiply negative 4 cos power of 3 exponent to y minus x power of 3 multiply sine exponent to y minus x power of 3, and then we need to multiply with 2 exponent power of 2y dy over dx. So it becomes like this. For the first step, we got the answer negative exponent power of 2y cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 dy over dx. The second step we need to solve it is negative 4 cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 multiply with negative 3 x power of 2. So we get the answer for the step 2 is 12 x power of 2 cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3. So the equation that we get is negative 8 exponent power of 2y cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 dy over dx plus 12 x power of 2 cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3, and then minus 2 over y dy over dx equal to dx equal to 4x dy over dx plus 4y. So then we collect all terms involving dy over dx, which is this, and this. And then we combine negative exponent to y cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 minus 2 over y minus 4x close bracket dy over dx, and then equal to 4y minus 12 x power of 2 cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3. So the final answer for dy over dx is 4y minus 12x power of 2 cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 over negative exponent power of 2y cos power of 3 exponent to y minus x power of 3 sine exponent to y minus x power of 3 minus 2 over y minus 4x. So this is final answer for dy over dx for the question 3.
In lesson, I will explain question number 4. Use linear approximation to estimate the value of 16.03 square minus 1 divided by the fourth root of 16.03. First, I define the function as fx equals x square minus 1 divided by the fourth root of x. Then, I rewrite it as fx equals x square minus x raised to the power of negative 1 over 4. Next, I differentiate the function. The derivative of x squared is 2x. The derivative of negative x to the power of negative 1 over 4 is positive 1 over 4 x to the power of negative 5 over 4. Therefore, the derivative is f prime x equals 2x plus 1 over 4x to the power of 5 over 4. Since 16.03 is very close to 16, I choose x naught equals 16. This change in x is delta x equals 16.03 minus 16, which equals 0.03. Next, I apply linear approximation formula. Fx naught plus delta x is approximately equal to fx naught plus f prime of x naught multiplied by delta x. Next, I calculate f16. F16 equals 16 square minus 1 divided by the fourth root of 16. Since 16 square equals 256 and the fourth root of 16 equals 2, f16 equals 256 minus 1 half, which equals 255.5. Next, I calculate f prime of 16. F prime of 16 equals 2 multiplied by 16 plus 1 divided by the 4 times 16 raised to the power of 5 over 4. We will make 32 plus 0.0078. Therefore, f prime of 16 equals 32.0078. Finally, I substitute the values into the linear approximation formula. F16.03 is approximately equals to f16 plus f prime of 16 multiplied by 0.03. This becomes 255.5 plus 32.0078 multiplied by 0.03. The final answer will be 256.460. In lesson, I will explain question number 4. Use linear approximation to estimate the value of 16.03 square